This is Meteorologist Tanja Fransen coming at you with another recap video and an unusual one. I normally don't do recap videos going over the summer season. I had to make an exception for this, however, because Medford has had a historic year in terms of the amount of severe thunderstorm warnings. 75 severe thunderstorm warnings were issued for the Medford area. This decimates the previous record of 43. So I'm going to be taking a look at that in this video. This was also presented at the most recent Oregon AMS meeting back on September 18th. This is also going to be a little bit more technical than a lot of my videos that have been, so just as an FYI, I will try to explain everything, but I cannot guarantee I will explain everything for the sake of time here. First off, the top 10 days of warnings, and just for context, the previous records were in 2017 and 1999 tied at 43. And the first thing I noticed was that 2025 had the most active day with 19 severe thunderstorm warnings on the 3rd of July. That's it here in the top 10. 2017 had 2 days here in the top 10, and 1999 had 3. That's despite 2025 having a total, well, of 60% more than 60 to 70%, excuse me, more than 2017, 1999. So that tells me, without even looking at the warnings, that it was more of a consistent thunderstorm amount rather than just having a lot on a few days. This is a line chart or line graph of all the severe thunderstorm warnings that have been issued since 1997 by year. Shows a pretty well defined severe season between about May 1st and the middle of September. This also means that I don't think we'll be seeing another severe thunderstorm warning for the rest of the year in Medford. The bar graph, however, is a much cleaner image to show how impressive this year was. Now, for context, a severe thunderstorm requires 50-mile-per-hour wind gusts or 1-inch diameter hail or larger. This was changed in 2021. Before that, it was 3/4 of an inch diameter or higher. So for us, or for the Medford region to get 75 is even more impressive now than it was before 2021. A severe thunderstorm warning is also a storm-based warning since 2007. Before then, it was county-based warnings. And the data set I'm using, which is whilst through the National Weather Service, before 2007, the Iowa State University's IEM database has adjusted these totals to 1997 to be a storm-based warning total rather than a county-based, which back before 2007, how the National Weather Service counted it was if 3 counties got a severe thunderstorm warning off of the same cell, count as 3 warnings. Today, that would count as 1. Some notes: no sea level pressure systems have been shown because everything was pretty much unimpressive. It was better to just look at the 500 millibar maps. Also, for reference, a severe thunderstorm watch criteria is when the Storm Prediction Center expects 6 severe thunderstorm warnings. None were issued over the summer months. One was issued back in the Portland area up to Seattle back on March 26th, which spectacularly busted if you want to see that failure of a performance. Please go back and watch either my recap video to find out what went wrong with that event, or the Art of the Bus video, which also has references to that event. Selected days have either CAPE, 500 millibar maps, the lapse rates, or skew-T charts shown. We'll start with the June warnings here. 13 severe thunderstorm warnings were issued here in June, 12 of which occurred on just 2 separate days, and then 1 isolated warning. First off, on June 10th, this had 6 warnings, 3 of which occurred just north of Mount Shasta. None of this produced any sort of reports, despite this cell being just to the northeast of Klamath Falls. The CAPE levels here, and for anyone who's unfamiliar with this term, CAPE stands for Convective Available Potential Energy, which is a measure of how much energy a thunderstorm has available to it to produce lightning, hail, anything significant. It's not really a good measure for tornadoes, however, because I need low level shear if I'm looking at a storm that could produce a tornado. The Cape values were over 2,000 just to the southeast of Medford, but it's primarily aligned with the Siskiyou mountain range. All these graphics here are through the Euro reanalysis at 5 o'clock on each day that I'm looking at, unless otherwise said with the text here. Moving on to June 30th, because June 10th had 0 reports to speak of, we had 6 severe thunderstorm warnings again. A little bit more scattered throughout rather than just 3 at one spot. Cape Map, however, was a little bit more unimpressive, though it was still situated around the Siskiyou mountain range with a peak cape of about 1100 and change. Skew-T charts. So for anyone who doesn't know how to read a skew-T chart, on the left here shows the atmospheric pressure as you go higher in the atmosphere, it gets less dense. And then just to the right here, it shows how high in the atmosphere each pressure level is. There are weather balloon launches twice a day in Medford. I'm showing the 5 o'clock one for each time I'm showing a skew-T chart here. The two things I'm paying attention to here is this lighter black line here, and then the darker black line here where my cursor is. So the darker black line, if that is to the left of the lighter black line, that that is showing that the atmosphere is unstable at that particular region, and that produces the Cape value. So this is a pretty reasonable amount of Cape value for Medford with a value of about 1200, which is actually higher than the reanalysis shows here, showing that there was least potential for thunderstorms. Though if you don't get a trigger for the Cape, it can just fall flat and nothing ends up happening. June 30th did produce one storm report, which was a wind damage report to the southwest of Klamath Falls. Now, also as a note that these reports from the Storm Prediction Center, the numbers on here are for the nationwide reports for that day, not for the region of the Pacific Northwest. On to July. 47 severe thunderstorm warnings were issued. That means that if you just take July and exclude June and August, this would still be the most amount of severe thunderstorm warnings issued in a year. A lot of these were concentrated right around the Oregon and California border. Start on July 1st, second day in a row of severe thunderstorm warnings, and this one produced what I like to call a Crater Lake staller, as a cell was pretty much stalled out right around Crater Lake with a few additional severe thunderstorm warnings. Cape Map topped out at around 2106, though this one was more aligned with the Cascades. Then also I pre-drew this on here to show the general setup of monsoonal moisture. An upper level low was situated off the coast of California, bringing in moisture up from the tropical Pacific into the southern parts of the Pacific Northwest. Did not penetrate into the Willamette Valley or the Puget Sound region until late in August. So as a result, all the storms are concentrated in the Medford region. Skew-T chart here for the Medford area shows a little bit more of a skinny profile, still pretty elevated with the unstable region ranging from about 4,000 meters in the atmosphere up to about 10,000 meters, so 12 to about 34,000 feet in the atmosphere. So pretty elevated instability. July 3rd was the big day. 19 severe thunderstorm warnings. First thing I noticed when seeing this map was a lot of severe thunderstorm warnings that just decided like, hey, I like that at welcome to Oregon slash California signs. I'm just gonna stick right over there and just dump. This because it was mainly in the mountains, there was only one storm report. It was a hail report that did reach severe criteria a little bit to the south of Ashland. I did not see any photos on this, however. The Cape map, pretty unimpressive actually for the Medford area. Cape Valley is over the spot I'm talking about, which is where my cursor is, was only in about the 2 to 300 range. Lapse rates were also pretty unimpressive here. And for lapse rate means that for an air parcel, it's how quickly it cools as it goes up into the atmosphere. And this is specifically the mid-level lapse rate between about 3,000 meters in the atmosphere and 5,500 meters in the atmosphere. So a lapse rate of 6.5 degrees Celsius per kilometer is the lowest I tend to look for producing thunderstorms. And for severe criteria, I'm looking at closer to about 8 degrees Celsius per kilometer or greater. Also, the upper level low did move to the north, but it also weakened. So that brought in more moisture to the Medford region, but because it was weaker, it couldn't bring up any further moisture into the Willamette Valley or points north. So taking a look at this radar loop here, one thing you will notice is that it's not just one cell that's parked off. It's cell after cell after cell that keeps forming. These yellow boxes are the severe thunderstorm warnings that get issued in the area. Medford's radar is located pretty close to where all these severe thunderstorm warnings are issued, but it is also pretty high. It's at 7,500 feet on the top of Mount Ashland. You can actually ski right by it, which is unusual for radar your sites being pretty close to the public. That's pretty high up by the way radar standards go, which means that it penetrates into these cells much higher up than they normally would. For reference, Portland's radar is at 1,500 feet, and most of the radars out east are closer to ground level as well. This is cell number 6 that we're looking at here, the final cell that moves through. So one theory that was come up with both by myself and at the AMS meeting was that a lot of these cells were did not actually verify severe thunderstorm warnings because that radar beam penetrates higher into the cloud, showing the more unstable part of it, but not reaching the surface as a result. Skew-T chart in Medford similarly shows a pretty stable atmosphere minus a small layer of instability between about 6 and 8,000 meters in the atmosphere. And the impressive thing about July 3rd, no storm reports at all. Didn't produce any sort of damaging winds or hail. I think some of that is because it was in the mountains, but because it went over I-5, I would have expected to see at least a few just seeing that many severe thunderstorm warnings. That furthers the theory that it was is a radar issue of it penetrating too high into the cell to get a truly accurate reading. July 7th here produced only 3 severe thunderstorm warnings all to the south of the Medford region. However, this is the first day that actually produced any sort of significant damage or light shows in the Rogue Valley proper. Reports showed 4 wind damage reports that were just reported to the Storm Prediction Center. More were reported to the local news stations. And taking a look at the Cape levels here, very unimpressive. Cape values were only in the 3 to 400 range. It was made up, however, by pretty good lapse rates right around 8.5 degrees Celsius per or kilometer risen in the atmosphere. And then the 500 millibar map here, the upper level low has reformed off the coast of California back in a more optimal position for Medford and brought in that moisture. Skew-T chart shows a more long and skinny profile for Medford. So, long and skinny profile means that the unstable layer is further up into the atmosphere. So this one goes from about 4,500 meters all the way up to almost 11,000 meters, but it doesn't produce a lot of cape through that parcel rising as a result. It can still produce thunderstorms as it showed here, however. Radar loop throughout, so this is different than July 3rd with everything being a southeast to northwest oriented. It's storms, which actually happens the most often with monsoonal type setups that have thunderstorms west of the Cascades. So the cell that reaches Medford here, which is right about where my cursor is popping up right now, and that does not get severe warned. The cell to the south does, and that's also because the cell does not look that impressive on radar that passed through Medford. Cell to the south did. This was the lightning map that was taken at 8 p.m. So this is a 30-minute look at how many strikes there were. I didn't get the exact number of strikes that occurred here, but when I zoomed out on my lightning radar app, it showed 1,000 plus. I would estimate this is about 1,200 to 1,500 strikes just in the southern Rogue Valley region. Medford here is right on this northern fringe of all these lightning strikes, and it was moving right towards Medford. This did produce a good light show over there as reported by the news stations, and I will link their social medias in the description below if you want to take a look at those reports. So you will have to scroll a little bit for them. It also produced some damage. This is Highway 234 between Medford and Jacksonville, and ODOT was forced to close the highway here due to downed power lines. National Weather Service in Portland's lead meteorologist Tanja Fransen had mentioned during the meeting that the wind required to topple these power lines would be about 85 miles per hour. That means that it would have actually qualified for a destructive tag, which is a special category of severe thunderstorm warnings, the highest tag possible. If the storm was warned to the damage it actually produced, that would have triggered the emergency alert systems on your TVs and phones. So pretty significant that we got 85-mile-per-hour wind gusts if that is true, meaning these poles weren't actually rotten inside. I don't think they were by the looks of the photos here. And there were more photos that were in the ODOT album. This is just the best one that I saw. Also, multiple fires were started. This is the best images I could find. Also, ODOT photos, the Neal Creek fire, which occurred on I-5 as you were climbing up to Siskiyou Pass. This is a lightning-caused fire. They thankfully put this out relatively quickly so it didn't blow up to be a massive fire, though evacuation notices were issued for portions in the southern Rogue Valley. Other effects, 22,000 customers of Pacific Power were without power, and 911 lines went down during the storm, which delayed the emergency response. They were down for about 12 to 16 hours, which is pretty significant. I don't exactly know why it went down. And I'm guessing it was because of power outages, but it was not outright said in their messaging. Right, so moving on to a little bit more tame weather in comparison. July 24th had 4 severe thunderstorm warnings, and one of them did produce a hail report and some minor flooding over in the Wairika area. July 30th was more of the more typical terrain enhanced severe thunderstorm warnings, with 5 of them occurring. July 31st, another 5 severe thunderstorm warnings occurred. This one produced Cape right around 1400. One thing I found interesting with this is that there wasn't really an upper level low to speak of, at least not in the 500 millibar or map, that was in any sort of position to bring in monsoonal moisture. The ridge was also displaced a little bit to the east as well, which is the other thing I typically look at. Skew-T chart here showed a long and skinny profile right over Medford, though they did not get anything to trigger this unstable atmosphere over Medford proper. Moving on to our August warning here. 15 severe thunderstorm warnings occurred in the month of August, most of which occurred on 2 days. First was on August 1st, the last of the 3 days of severe thunderstorm warnings, also being primarily in the mountains. Cape Map showed a more typical Cape Map of the most energy being over the mountains, specifically the Siskiyous in this case, with Cape values approaching 2000. Then the last day that I will be covering is August 26th. 7 severe thunderstorm warnings were issued, including a few that were over Grants Pass, which is the second most populated city in the area for anyone who is unfamiliar with that portion of the state. Cape values were also the most impressive of the summer. Almost 2,500 was the Cape value at 5 o'clock over Grants Pass. Lapse rates were also right around what I'm looking for a severe thunderstorm, at about 7.5 degrees Celsius per kilometer in the mid atmosphere. And then there was also an upper level low situated off the California coast, with a pretty good ridge position extending into British Columbia, bringing monsoonal moisture towards Medford. And this also brought the monsoonal moisture further up into the Portland region and closer towards Seattle. Skew-T chart for this. Medford proper escaped with another skinny profile, though this one is far shorter than the previous long and skinny profiles we saw before. The radar loop in this case, unlike the previous cells, these were cells that just partied out for a while. That's what triggered the flash flood warnings in California. And unlike severe thunderstorm warnings, flash flood warnings can stay on there for hours at a time. Severe thunderstorm warnings generally are only active for about 30 minutes at a time. This cell here in Grants Pass, the one that just got warned here in that yellow polygon, that is the one we are looking at for damaging hail or winds. It did finally peter out right at around 8 o'clock as another cell tried to form, but didn't form as well as before, as it lost the daytime heating required for thunderstorms and didn't have as much lift as the other cells have had. So these were hail reports on the social media platforms for KDRV News on the left here and KOBI News on the right. So these are the two major stations down there. So these shows those hail right around an inch in diameter. These aren't using calipers, which is the way I personally would recommend measuring hail, because you get a far more accurate reading than just using a tape measure. An inch of hail is enough to do damage, though thankfully I did not see any significant damage reports or any injuries from this. I'll link these two social media posts in the description below on top of their pages. And then on to our main takeaways. Terrible hiking weather this year if you're down south. Most thunderstorms either needed or were enhanced by terrain. This was one of the reasons why there was a lack of reports because the mountainous regions tend to be more forested. Really, there's only 2 days that had significant Rogue Valley thunderstorms that produced severe level winds or severe level hail. Also, oh, like mentioned earlier, the radar being perched higher up than comparable National Weather Service sites probably contributed to the amount of severe thunderstorm warnings, though this has been a problem in previous years, so it does not matter when it comes to the sheer number compared to the 2017 and 1999 records. Most storms also involved monsoonal moisture. This monsoonal moisture was also a reason why it was more humid than usual in the Portland area this year. Even if we didn't see any from thunderstorms until late August and into September. Last thing, I added this for fun, is just a comparison of the Pacific Northwest's National Weather Service offices. There are 7 that cover the Pacific Northwest. The one that has the least amount of thunderstorms is the Seattle region, only averaging 2 severe warnings per year. Portland comes in next at 8, Medford's 13, Pendleton, Spokane right around 20, Boise a little bit higher at 33, and then Idaho Falls at 52. The yearly record for Seattle is actually the same day as the previous record for Medford in 2017. That also contains their previous daily record, too, same day of May 4th. Portland's record came in 2008, Medford's this year, Pendleton back in 1997, Spokane and Boise back in the mid 2000s for Spokane and Boise recently in 2022. But Medford numbers shares more in common with the east of the Cascade stations than it does west of the Cascades. Then Idaho Falls out in its own league again with 105 warnings back in 1997. The daily records, Port- Portland's a little bit unique here. Now, when I'm saying severe warnings, this does include tornado warnings because tornadoes are produced by severe thunderstorms. Generally supercells, though not always. 10 of these 13 severe warnings on October 14, 2016 were tornado warnings, one of which produced the EF2 tornado that went through Manzanita. Otherwise, the records were right around 20, regardless of which other National Weather Service office you picked. The total tornado warnings, pretty much all around 10, Medford being in last place at 3, Portland being in second place at 25 warnings, and then Idaho Falls again in its league of its own at 101, which you gotta keep in mind, however, that that is a flatter part of the Pacific Northwest, and it's also easier to get monsoonal moisture to come up from the Gulf of California and the tropical Pacific out there. So that is it for this video. I hope you enjoyed that little special feature I have here. I will see you all in the next video. There should be one PNW Weather 101 episode out before my winter weather forecast is out in mid to late October. So stay tuned for those. Until then, stay safe out there and take care.